Welcome back. Let's revisit the conclusions from our last meeting on peak packaging last April 26th. And to do that, let's travel back in time. With all the discussions, I put together this slide. For me, there are 4 demands here. On one, we really had to have an assembly design kit for the OSATs to be able to offer the technology all in line. And I agree with Gunther, it's going to be a hard task, but we love those. The second demand is on the RF connectors. We've seen that modulators are getting faster and faster. Like when Logic already has 70 gigahertz plus modulators, we need to have novel RF connectivity for that. The third one is test before invest packaging for many different applications that we are targeting. Indeed, we are talking about 3D sensing, we are talking about medical devices. All these new end users need to find a way of test before invest, and a standard package application dependent is a huge unmet need. And the fourth one, micro optics are coming here to reduce cost effectivity for the fiber array assembly. I do believe this is a huge market for all of us. And there have been some seismic shifts in our industry since then. For example, Epic member Lightwave Logic had good reasons to ring the NASDAQ closing bell.
And the exciting thing now is being listed on NASDAQ allows us to go faster. It gives us access to wider and more open capital markets. We can get our technology to market quickly. We work with bigger semiconductor foundries, and we can go mass commercialization scale, which is incredibly exciting.
And of course, Epic member Rockley Photonics, who after ringing the opening bell on August 12th, raised global attention for the use of silicon photonics to bring biosensing and specifically glucose monitoring to the consumer market. The legendary Andrew Rickman can explain it better.
And so we're able to measure a whole plethora of biomarkers continually, using the optical signal coming out of the chip, shining into your skin harmlessly, and looking at the light coming back. But all the parameters that we're able to measure here, we ultimately hope that we will be able to get FDA clinical approval for them. Yeah, so this is a reference device that we use for our human studies and to help our customers. Our customers are, the global leaders in wearable device technology and wearable devices. So yeah, we're providing basically the chip and module technology into those devices that open up this huge array of biomarkers.
I believe we are entering the most exciting era in the history of photonic integrated circuits. That's why on Monday, October 4th at 3 p.m., we will reunite our community of packaging specialists back together, including industry drivers like Rockley, Effect, Pixap, IBM, AIM Photonics, Intel, Philips. There is not enough time to mention you all, so check out our website because we keep the participant list updated constantly. And if you are not on the list, register ASAP. Wow, Michael Levy, Andrew Rickman, thank you for being epic. Cheers. Cheers. Cheers to everyone. These have been the most exciting months since our previous meeting, the most exciting months on photonic integration history with great success stories. Today we are bringing many of them back. Remember that during this meeting, you can interact with each other, and the participant list of all the companies, 120 companies, is published in our website. So you can actually get in touch as much as possible and start new cooperations. Epic is now 750 members, and thanks to all the amazing support that you are giving us. My name is Jose Pozo, and I'm talking on behalf of a fantastic team. Together we organize events, we provide access to the network, we'll help you raise capital. We have the biggest website in photonics, jobsinphotonics.com, and we also, thanks to our star Tracy Vanik, head of Photonic Market Research, we provide you with exclusive market data. All of you, because you are members of Epic, all of this to you. But today is our chapter 6 of our season 5 of our online technology meeting. And on this chapter 6, we are talking about packaging and testing of PICs. Take a special attention. Look closely to what's happening next Monday on laser vision correction, and also what is happening this Wednesday with our quantum online technology meetings. This Wednesday we talk about atomic clocks, the most precise clocks in history and how they can be used in network synchronization. But today is all about peak packaging and testing, and this meeting wouldn't be possible without the support of our sponsors today, coming all the way from Switzerland. If you're looking for a micro-optics partner, that partner you need for the co-packaging and for the wafer-level optics, Attendees is your key partner there. If you're looking for equipment for the assembly and test, focus on active alignment all the way from Aki next to Bremen in Germany, you have Photonic. If you're looking for a partner to design a probe, a wafer probe for the scanning and test of wafer-level photonic integrated circuits, Genoptic is your partner. Whether you're looking for a European OSAT to do the manufacturing at volume of your photonic integrated circuit-based module, Fix in Enschede, Netherlands is your partner. If you're looking for a company provide the testing, the broadest portfolio of high-performance photonic test and measurement equipment comes from Keysight. And if you still haven't called VLC Photonics for your testing, congrats VLC Photonics for so exciting accomplishment on testing assemblies and wafer scale process coming all the way from Sweden. We have Nyforce because they provide a specialty fiber and fiber assemblies for the fiber to chip coupling. And last but definitely not least, the leader of the European micro-optics revolution coming all the way from Neuchâtel, SUS Micro-Optics, providing micro-optics wafer level optics for your co-package solution in photonic integration. And with these sponsors, we have put together a great agenda. We wanted to bring together the most exciting things happening in photonic integration when it comes to the packaging and assembly. And with this, we brought Pixap, IBM, Effect Photonics, Rockley Photonics, Ipronics, Rod Microtech, and AIM Photonics. And all the companies registered, more than 100 companies registered for this meeting, we put them together into this supply chain. So this is the useful for this. If you are looking for a supplier of products based on PICs, that you have all the companies there. If you're looking for a company that can help you with the design or support for manufacturing, or you're looking for equipment, you're looking for materials, all these companies with logos are so small you almost cannot see them. All these companies are in the meeting today, and all the name or the contact people for these companies are in our website, at the website of the event, so you can really get in touch with each other over the next 2 hours. Do a favor to me. Over the next 2 hours, create at least one business lead, one contact with whom you want to cooperate. And to make things more exciting, this meeting is also live streamed in YouTube. So hello, YouTubers of the world. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epictasasac.com, and I will make the introduction. Please post all your questions and comments in the chat, and I will read them in the Zoom room. And of course, this is also valid for the people with me here in the Zoom room. There is an internal chat, so use it, abuse it, contact each other as much as possible. I want to see you typing during the meeting because this meeting is about creating business. And when it comes to creating business, there is a success story in Europe when it comes to photonic packaging. And they are headquartered in Cork, Ireland, but brought together the entire Europe, offering leading services and training on photonic integrated circuit packaging. And to start our packaging meeting today, we have brought to you the director of Pixap, that person that you always want to meet and he's always too busy to talk to you. Today he's here to talk to all of you, Professor Peter O'Brien. Thank you very much for being with us today. The floor and the attention of everyone, the very well-deserved attention of everyone, goes to Pixap.
Thanks, Jose. Thank you very much for that kind introduction. So I'm going to talk a little bit about Pixap, but I think you've probably seen a lot of what I've presented before. And really what I want to talk about today is just around design rules and getting access to lots of chips and how we can utilize those to optimize packaging processes. So historically, I've spoken a lot about our services and what we're doing in that regard. And, you know, I have to make people aware, a lot of that's through our industrial partners like Fix and Argotech and others. So, you know, in Cork, we facilitate a lot of that through our pilot line. But as I say, what I want to talk about today, when the time I've been allocated, is what we're doing to kind of move things on a little bit, and how we're using things like reference devices and how we're working with other organizations like AIM Photonics. I'll mention that briefly, to collaborate in you know, lessons learned and work together. So again, you've seen some of these shots before. This is one of our labs in Cork, and we've recently invested in a new lab, and Photonic have set up a facility with us in our lab, so and installed equipment. So here's Josue Parra from Photonic. So we have engineers and equipment at Tyndall, and you can see two systems here, an F300 and a CL1500. So the right machine is actually quite an advanced system, laser soldering and die attach flip chip, quite high precision. So that's really kind of given us an ability then to do more development work and expand in looking at more challenging packaging requirements. So again, just very briefly to touch on what we offer is a range of capabilities, and something that you see on the bottom left-hand side is a prototype development service. So we have a range of very basic, or I wouldn't call them basic, but more simplified packages which are open. Rather than kind of more complex, kind of inexpensive, sometimes gold box solutions, where they're very good for prototype development. So following standardized design rules that we have, it's relatively quickly to turn around a package if you follow the design rules, and you can make a fairly sophisticated large number of fiber connections and electrical connections as well. We also have a training program which is running very well. It was hit a bit with COVID, obviously, with travel, because it's a hands-on program. But with the new Photon Hub Europe activity, we have what we call an experience center. So you can come to Tyndall for 3 days, as with many of the other centers within the Photon Hub Training Academy. And obviously, we do a lot of work. Here you can see a nice picture of Anna, who's not with Epic anymore, but I think she's talking today. But many of the Epic partners are great in supporting us. We were at ECOC, and that was a really, really nice meeting in Bordeaux about 3 weeks ago. And then road mapping and standards, so helping in that regard. I might have mentioned this before, but it's becoming very, very important to help us kind of work towards standards. So you're probably very familiar with on the left-hand side where you have Foundry, PDKs, process design kits. So essentially, if you go to an IMEC or if you go to AIM Photonics, different foundries, albeit there's more than silicon. We have indium phosphide and silicon nitride. Foundries like Linex and the JEPICs, Smart Photonics in Europe. So they have PDKs, and essentially what you're doing is you're laying out your chip in regard to the foundry process, the front end clean room process. But we've developed ADKs with one of our partners, Synopsys. Essentially that can be brought into the design software environment, and that would cover things like fiber optic packaging, micro optics, even 3D printed micro lenses. Vanguard are a partner in PIXAP, and different types of electrical packages. So flip chip, wire bonding, ribbon wire bonding, even laser integration. So in the bottom right, you see a hybrid laser with micro optics. And these can all be brought into the design environment to simplify the layout and more automated. So in a sense, you got the device building blocks on the chip, but also packaging building blocks. And that's slowly evolving. So it really simplifies the simple menu that you can use and how you implement that. So again, we have these chips. This is the SOI. We have got them for indium phosphide and silicon nitride. We call them the reference chips with a whole array of different types of devices on them, so we can validate the packaging processes. And I believe Stefan is talking later on. So Stefan from AIM Photonics. So we started to work with AIM in the last year very closely, more around training. So for training, so we're actually having cross, travel. People from AIM and people from Tyndall, for example, will be moving across the Atlantic, working. So we're expecting some visitors from AIM in the next month. Here you can see they basically mimicked what we've done in our reference chip coming out of the IMEC SOI foundry. You've got an AIM chip here. So Stefan and his colleagues Tom and David Harmay in SUNY in New York have been working on that, and we're starting to work together on that. So this is kind of moved on a little bit from our reference chip. We have micro optics in there as well, and we're working towards kind of more common standardized approaches for packaging. So using the foundries to standardize the layouts for packaging. So you can see kind of similarities, things like pitches, edge couplers, grating couplers, flip chip wire bond for flip chip packaging, electrical packaging, wire bonding. So you're starting to see we're working together with different large-scale consortia to kind of develop those. So on the top, you see the reference chip, but actually something we've started to do a bit more of, and it's kind of also with a new project we have called Photonic Leap, is to, in a sense, mimic what we're doing in the photonics domain into the electronic domain, because co-packaging, for example, is becoming very important in many applications. For example, in data centers, we are packaging the electronic ICs, for example, drivers and modulator drivers, amplifier chips, onto a interposer. So from that perspective, what we're doing here is developing these, what we call reference chips. So these would be simple chips, nothing fancy, but they mimic the heat, for example, in an electrical IC, or mimic the RF interconnects. So we're not using very expensive chip platforms. And this enables us then to develop up a range of different packaging scenarios. So, for example, you can have RF mimicked RF ICs. These can be wire bonded or flip chipped, and mimicking the thermal characteristics of a chip. Looking at different types of interposers, be that ceramic or silicon or even glass. We're looking at glass as well. So how you interconnect between a high-speed electrical chip and a photonic IC. And then, for example, how do you set the spacing? So it could be you have a passive chip, a photonic chip, but you might have a lot of heat being generated by electronic IC. So you don't want crosstalk. So what is the distance? So these chips enable us to be able to kind of analyze that and come up with more complex design rules. So historically, the design rules are very much just on the layout. So now what we wanted to move is towards the layout of the package. When I say the layout, it was the layout of the chip. So how you lay out the chip to configure, for example, with fibers, to configure with wire bonding, etc. Now what we want to do is how do we configure the photonic chip with respect to other chips? So heating chips, RF chips, they can be quite complex and difficult to do. And what you don't want to rely on is the actual working chips, because quite often, as you're probably well aware, they can be difficult to get. If you're working with an MPW service, that can take a long time. So it really impedes the kind of speed of development for these types of scenarios. So these reference devices in the photonics domain and in the electrical domain are something we're starting to manufacture and utilize those to really look at the different scenarios for packaging. So something else we've done in PixApp is starting to make lots of chips. So for example, this is a device, a wafer we've produced with one of our partners, Linex. So these are 10 micron mode adapters in their silicon nitride platform. And we also have interposers where we modify the input waveguide from 3 to 10. And essentially we can make hundreds of these chips. So again, this is something that's always been a bottleneck in packaging, where you might be working on a process, but through an MPW run, you might have 50 chips if you're lucky, or with a customer, you might be limited. So what we're doing here is developing a process where we have hundreds of chips and thousands of chips. And similarly with our partner SUS, who are again a PixApp partner, and we're making hundreds of micro-optics. So in fused silica, for example, so we can automate processes where we're putting micro lenses onto the edge of PICs. So this is kind of like an important development, because one of our big issues is in packaging development, we don't have access to enough devices. We don't have access to versatile devices. So looking at how we arrange the package, look at how the spacing, how we organize it on the interposer, and have lots of them as we start to scale up and develop and automate that process. So just very briefly, I mentioned about this new project we have, Photonic Leap, and the idea here is we're developing a surface mount package. It's on glass, so it's a wafer level, and we can go to panel level where we're putting vias in the glass and using the glass base as an interposer. We're sealing the glass from the top and hermetic sealing, and outer plane couplers using micro-optics where we can have fiber connection at the top side. This enables, as we lay out the actual glass base or the interposer, we can have different package configurations. So it opens up the possibility of multi-project wafer runs. So we can go from low volume to large volume. And because it's a ball grid array type package, we can do automated wafer level test. So this project's really just started. It started this year. And it's linking in with some of the developments within PixApp and kind of working together. And we'd like to see other European projects, for example, where we can support them through our pilot line. So I'll just leave it at that to open it up to any questions people might have. But just to say, really, developing the standards is important. And it's not just in the chip, how we lay out the chip. These reference chips I've been talking about for a number of years, but also how we lay out the package. So we're developing kind of like, in a sense, reference interposers and how we lay out, spacings between chips, if they're thermally sensitive or if they're generating a lot of heat, if they're very demanding from an interconnect, from an RF interconnect perspective. We're seeing more connections required for fiber, pluggable connectors using micro-optics where we're not bonding the fiber. Epoxies are a really big challenge because they need to be reflow compatible. So looking at high TG epoxies, we have some good progress in that area. Wafer level is becoming very important. I mentioned about photonic leap. And essentially packaging somewhat is moving from the back end into the front end. It's moving more into the clean room at wafer level. And design automation is becoming very important, where we're looking at this using design rules, but also linking up the different domains, electrical, thermal, and mechanical. So I'll leave it at that and open it up to any questions. Thanks, Jose.
Thank you very much, Peter, and congratulations on what you have achieved over the last 4 years of PixApp. Congratulations also from the European Commission, all the great feedback. You're doing a fantastic and amazing job. Micro-optics. We are living the European micro-optics revolution. I believe that the wafer level optics that you can get from Europe right now with companies like Attendees or SUS or Nanoscribe, they are an example to the whole industry. You already explained very clearly how you foresee the role of micro-optics in the packaging. You mentioned some of the materials, you mentioned fused silica. I would like to hear a bit about your vision and, most important, your needs, your unmet needs still for the micro-optics in the packaging of photonic integration.
Yeah, so I think one of the big issues that we face is around the bonding materials. Like epoxies can be very, very, most cases they're not great. So people talk about reflow compatible. What does that mean? So a lot of epoxies were developed for things like LEDs, but when you're down at a micron precision alignment requirements, these epoxies often can expand. They may not contract. So under reflow 260, for example, they may not recover their original position. We can see them fail. So they soften to the point where multiple cycles can cause a problem. In quantum, we see interest in cryogenic cooling. So we've seen epoxies fail. So it goes from one extreme to the other. And there are interesting materials. So you can end up with kind of two-part type epoxy solutions where you have a mechanical, you might have an optical epoxy, you need to partition them, things like that. But also solders are becoming interesting. So replacing epoxies with solders. So metallizing the microlens so you can actually solder the materials into place. So I really think around the materials, the packaging materials are where one of the big challenges that need to be addressed.
Micro-optics are fantastic. The first time we met 15 years ago, Peter, you already made a difference in the packaging of photonic integration because you added console simulations when nobody was doing them because you knew that temperature was the biggest issue. There are two companies in the room who I think need to interact with you at this stage. The first one, and you know them very well, is coming all the way from beautiful Karlsruhe. It's called Nanoscribe. And Nanoscribe has actually a very interesting question for you. George, what's on your mind?
Hello, everybody. Nice to be back here again here. Peter, I have a question. You talk about a lot of standards. You have AIM now on the board, so you're cooperating with them together. So my main question is, do you have any idea how much the standards are accepted worldwide? Or is it a difference if you say EU, US, and other countries? I mean, most of the foundries still have their own standards for coupling, measures for spot size converters, anything, you name it. So are we at 50%? 20%, depend where is it better, EU, US, are you able to measure this?
Yeah, so it's a good question. Really, there's no soft standards. I call them soft standards. What we're trying to do is get everybody moving in the same direction. So collaborations with people like Stefan and AIM, we're starting to kind of speak the same language. We're starting to kind of lay out devices in the same configuration. we're sharing our experiences. I think the you got the other challenge then is you got different foundries, as you say. There is a move towards higher mode sizes, so more compatibility with single mode fiber. So moving from 3, you often see this 3 to 6 to 9, 10 microns at 1550. It's moving there. To kind of fix standards now might be too premature. However, what I would say is there's best practice. So laying out edge couplers in a particular way. I don't think anyone's doing that anymore because there's so many courses, you know, pitches and so forth. So really hard and fast standards, no, not yet. But people are starting to kind of realize what's important, and it'll probably take time to you know, a couple of years before we start to see things being documented and being fixed.
Furthermore, you should know, Peter, that over the last years, we started having these packaging houses, these packaging centers, these European OSATs like Fix and Technovis, so you know them very well. What we are seeing lately is also testing houses, like Maple or like VLC. I believe we have somebody from VLC in the room. Alberto, buenas tardes, good afternoon. Yeah, I wanted to talk to you at this moment because I wanted to understand, Alberto, how it is to set up a testing facility or photonic integrated circuit and also see if there is a room for cooperation with PIXAP. Alberto, we cannot hear you. That makes me nervous.
Maybe now?
Yes, loud and clear.
Perfect. So, good morning, good afternoon, everyone. Yeah, I think so. There is room for cooperation with PIXAP. Of course, we are quite interested on yeah, all the information. Can you hear me well?
Loud and clear. Okay, perfect.
So yeah, but at VLC we have been working on a high contact machine to be flexible to adapt all the needs from our customers, which is quite ambitious. And you probably are aware of the complexities of building a setup, an optical setup, which requires adapting the equipment, the tools, modifying for the different couplings and the performing on the electrical methodologies. So yeah, that goal that we are trying to get is quite ambitious. And of course, I guess being aligned with standards and with good practices to make it more flexible, more accessible for customers and for everyone to have a good configuration of these machines, it's a need.
Thank you very much, Alberto. Peter, do you foresee PIXAP being also the entry point for testing and has been the entry point for packaging already?
So we already do some testing with our partners in TUE. So they've been working with Photonic and developing. Sylvester in TUE has been doing quite a bit of work in that as well. So they have a test machine developed with Moritz, for example, in Photonic, and that's ongoing. But absolutely, you know, keen to kind of expand that. I think one of the big issues we face in all of this, and it's probably my takeaway message. I always try to give it what's the takeaway message. We need more chips. We need a lot more chips for development. I think that's one of the big impediments. You know, even in PIXAP, we find we work with some big companies and they can bring in more chips, but it's not lots of chips. And I think that's a big problem. And the chips all have to be managed very carefully. You can't use them for development. So this was kind of almost out of frustration. Like the design rules, we started out of frustration in some sense. We wanted to make more chips, make them cheap, make lots of them so we can, you know, give them out to people, but also use them ourselves, because I think that is one of the big problems. So getting lots of chips and access to them so you can optimize, run automated processes. So, for example, I mentioned about getting hundreds of chips. We need
cooperation with foundries. You mean to further cooperation with foundries?
Well, not cooperation. You have to pay them to get them. So it could be like maybe everybody comes together and does a run where we get lots of chips each. But it's just getting lots of chips is a big problem. So that's what I mentioned in my presentation. Something we're starting to work on. We need more and more devices, even generic ones.
Thank you very much, Peter. Before we go to the next speaker, that he's desperate already, and I know that he's fantastic, I want to address your challenge on the glues that you need, the adhesives that you need for the micro-optics to photonic integrated circuits. And for this, I want to go to one of the PIXAP partners and the leader of the micro-optics revolution, SUS Micro-Optics. Wilfred, good afternoon.
Oh, how are you? Thank you
You
very
are
much.
giving micro-optics to many of the leaders in many sectors, including datacom, telecom. Is the adhesives from between the micro-optics and the integrated photonics a challenge?
Oh, there's a lot of challenges. So especially if we need to integrate more and more features. So this is actually becoming very tricky. And but we have some solutions there, and depending on the application, and we offer more and more extra features. Can I share a slide? Or?
Yes, please go ahead. Of course, everybody can share one slide.
Okay.
One.
So here we go. So here I have an overview of the different features that we offer, and actually some of these we provided for PIXAP. So Peter has them on his desk, so metaphorically spoken. But we also have a lot of special features now that we want to further develop in Photonic Leap. For example, the what you see at the top right, the mirrors, the integrated mirrors that allow you a 30 degrees turn. So this is a highly integrated design which can facilitate your packaging tremendously. So it's actually already a product, but it's a custom design for one of our clients, but we want to give it to a broader community by offering it through Photonic Leap. At the same time, we have we offer soda bombs and also through silicon vias that should all make your packaging much easier. And this is actually also a very common design that we produce in high volume. These are what we call the recessed lenses when you want to stack. And here we also gave a bunch, this is, like I said, a volume product, but this is also a design that we provided to PIXAP, and which is available through Photonic Leap probably as well for different companies for packaging tests.
Thank you very much. And to add to that, we have CSEM in the room. Stefan, thank you very much for joining. Stefan Mordic from CSEM. What's on your mind?
On my mind.
Yes,
So,
yeah, tell us.
yeah, I was thinking about the adhesive bonding, which should sustain high temperatures. I was wondering why you wouldn't go here for, say, regular bonding schemes, and if you want to make it rugged, so adhesives, so they have some disadvantages in the long term, so they may creep, and there's water ingression if you want to get stuff hermetic. So I was wondering if there wouldn't be any other types of technologies you could use here for fixing components. Or actually, I'm not wondering. So there are. I mean, you can solder any type of component, and if you can do it on a, say, low-cost path, then it would be a big benefit. I think there's some opportunity here for the research community to improve.
Yeah,
it's a good point, Stefan. The issue is that we don't have a machine that can do the soldering and the alignment in one go at the moment. So there you go, Photonic. There's a challenge for you.
So I agree here with Stefan, in which we cannot reinvent the wheel. We are having one event on micro-optics almost per month because it's one of the biggest markets right now in the European optical community. And there we are talking about new materials constantly and ways to deploy them and ways to actually use active and passive alignment. So I believe that for photonic integrated circuit, there is, and Wilfred, Sus, you have to be the link here between two communities. We have to build stronger bridges to make sure that the technology of fabulous pilot line, for example, can benefit the technology of PIXAP. Peter, thank you very much. Stay with us because I'm going to come back to you a bit later. But now I'm going to go from Ireland all the way to Canada. And I want to go to Canada because I want to talk to Alexander Janta, our main contact in IBM Bromont, to tell us about what happened in the last months and also tell us how we can strengthen new cooperations. Alexander, thank you very much for interacting with so many members after the previous meeting. The floor and the attention of everyone goes to Bromont, goes to IBM.
Thank you, Jose, for the introduction. So, hi everyone. We're really happy to be there today. Today, I will present some of our offering for photonic packaging, and I will also to disclose there's this new satellite initiative from Europe and Canada, and there's some incentive to collaborate together because there's a need for this interoperability of this new internet in the space. So today I will present some of our packaging building block, and as you know, those novel space technology will use